EIS Symposium 2025 Student Poster Presentations, Analysis, and Reactions. Howdy, this is the EIS Symposium Oral Report for ECCB 205 under Dr. Jacqueline Grace. Unfortunately, I was unable to properly ascertain with certainty the professional level of the researchers in the poster presentations, although I can say with some certainty that almost all of the researchers were most likely undergraduate or graduate students. Number one, share the shore, y'all. Reducing recreational fisheries bycatch in Texas through education and outreach. The research for this one was conducted by Caitlin A. Vargas and Pamela T. Plotkin of Texas A&M University. The Texas shore is a developing nesting and stranding site for sea turtles. Simultaneously, it is also the location of a $1 million recreational fishing industry, which can harm turtles. If turtles get hooked and or snagged in fishing lines, they can be harmed, maimed, or even killed. In the event of this occurring, there are hotlines and other methods in place to ensure the proper handling and release of the turtles. However, the data of the research suggests that most people either do not know what to do when catching a sea turtle by mistake, or have tried before to use the services and have been met with barriers, leaving them to take matters into their own hands after each subsequent accidental capture. The primary focus of the research was to determine how many people were aware of the hotline and if they used it. The results suggested that it was usually not used or that people were unaware of its existence. This is because of conflicting signage established at different fishing spots, threatening rhetoric on the existing signs that made anglers fear legal action or fines, a language barrier between Spanish-speaking anglers and the English-only hotline, and little advertising of the hotline in the first place. Proposed solutions were increasing frequency and volume of signs containing hotline details in both English and Spanish, working with Texas-based fishing organizations and creating training about what to do in such a situation, and updating the hotline to be more user-friendly. Overall, I found this research to be very interesting, especially as a fisherman myself. While I do not spend much time fishing on the coast, with a steady access of bodies to water within my own hometown, I will certainly be more conscious of my fishing lines and casting along the Gulf Coast the next time I take a fishing trip out there in order to protect the sea turtles. Presenters of this poster did a wonderful job in their presentation and left me with no questions. Number two, habitat use and movement of collared peccaries, Peccari tahiacu, or javelinas associated with the U.S.-Mexico border barrier system. Research conducted by Emily A. Masterson, Edward M. Tomasetti, Daniel J. Benson, Abigail N. Dwell, Jacob L. Dykes, Walter E. Cook, Whitney J. Gann, Stephen L. Webb, and Marcus E. Blum of Texas A&M University. Collared peccaries are a medium-sized terrestrial ungulate native to a range from South Texas to mid-Latin America. With the construction of the border wall on the Texas-Mexico border, peccary's natural habitat has been fragmented. The objective of this research was to capture, tag, and study the effects and adaptive strategies of the peccaries along the border. The researchers conducted their research by placing wildlife feeders at specifically identified locations, trapping the peccaries in humane wildlife cages, and collaring them with GPS collars to track their movement. Data from the preliminary research suggested that wildlife crossing tunnels integrated into the wall were effective means to allow said peccaries to move freely through the barrier at any time. So therefore, the fragmentation of the collared peccary's habitat was not as severe as originally thought. However, the research is still ongoing, so the results and data specified are still subject to change with further investigation. There were also some recommendations suggested by the researchers in order to mitigate the negative effects of the border barriers installation. Those included increasing the number of wildlife crossing tunnels, modifying lighting installations to encourage the peccaries to use the habitats, and reducing human activity where possible in the area. Similar to the previous poster, this one also affects my hobbies, as I often encounter collared peccaries or javelinas, as they're more commonly referred to, while hunting in South Texas. My main question for the presenters would be, what other species are affected by the habitat fragmentation of the border barrier system along the Texas-Mexico border, and what other methods can be used to reduce the ill effects of the fragmentation in the region as a result? Number three, water depth preferences of female Gambusia affinis and the role of predator cues. The research was conducted by Colby DeRocher, Gage Goodgame, Derv Sharma, Samantha Yapes, and Caitlin Gabor of the Texas State University Biology Department. Gambusia affinis is a very tolerant invasive species native to the southeastern to south central United States. However, it has taken up known residence now on all continents except Antarctica. Mosquito fish, as the Gambusia is better known, preys on the larvae of mosquitoes and has been introduced globally as a means to combat mosquito vector diseases. Before populations began thriving and expanding rapidly in their new environments, the purpose of this research experiment is to analyze the preference. I'm sorry, excuse me. Mosquito fish, as the Gambusia is better known, preys on the larvae of mosquitoes and has been introduced globally as a means to combat mosquito vector diseases. Before populations began thriving and expanding rapidly in their new environments. The purpose of this research experiment is to analyze the preferences of Gambusia for water depth depending on different circumstances. There's a noticeable trade-off among depths, with deeper water often allowing better access to resources while shallower water provides protection from predation from bluegill sunfish, a common predator of the Gambusia. The researchers hypothesized that the Gambusia specimens would prefer to spend time in more resource-rich, deeper waters. Furthermore, they predicted that when introduced to chemical cues associated with the sunfish predation, a majority of the Gambusia specimens would migrate to shallower waters within the testing environment for better safety. Lastly, they assumed that the Gambusia, who are continuously exposed to sunfish predation chemical cues, would display the shift from a fundamental niche to a realized niche by primarily occupying the shallow water within the testing environment. In this experiment, the researchers conducted the control group by releasing 20 female Gambusia in a plus-sized container with two deep arms measuring 9 centimeters deep and two shallow arms measuring 6 centimeters in depth. Over a 10-minute period, each arm was counted for how many Gambusia occupied it and for how long they remained. The plus-shaped container was rotated 90 degrees after each test. In the second experiment, utilizing predator cues of bluegill sunfish, the researchers released 14 new female Gambusia into the testing environment and injected the chemical cues from 3 different sunfish into the environment and followed the same procedures for measurement as the control experiment. That is, measuring the amount of time and number of Gambusia that occupied each arm over a 10-minute period. The results actually disproved the researchers' hypothesis. Rather than avoiding deeper waters when met with predator cues, the Gambusia seemed to prefer the deeper environment regardless of the predation cue variable. In fact, Gambusia seemed to move between arms less when faced with the predation chemical cues, suggesting that chemical cues alone were not enough to induce escape behavior in Gambusia. In the conclusion of the experiment, the researchers made some suggestions about potential improvements that can be made in the experiment to produce different results, such as increasing the difference in depth among the deep and shallow arms of the maze or redesigning the testing area altogether. The results of this experiment surprised me, as I had a prediction similar to the disproved hypothesis that the researchers made. I actually have a recommendation for the researchers that I would like to suggest. Perhaps in their next experiment, they could redesign the testing enclosure to be more similar to the natural environment of Gambusia, and rather than introducing chemical cues, perhaps they can introduce a single or multiple bluegill sunfishes. Thank you for your attention, and gig 'em.